It's the multiplication assessment worksheet number 11. Ms. White is laying tiles in a room that measures 240 square feet. If the room is 80 feet long, how many tiles does she need? So they told us that she's laying tiles in a room that's 240 square feet. That's area, isn't it? So this room is 240 square feet. The room is 80 feet long. How many tiles does she need? You know what? There's a typo here, I think. We don't know how many tiles she needs because we don't know how big the tiles are. But should we go ahead and pretend like the tiles are 1 square foot? So if the tiles are each 1 square foot, how many tiles will fit here? Pause and think about that for a minute. Remember that area is a measure of how many squares fit on top of something. If this area is 240 square feet, that would mean literally that you could put 240 squares that were 1 foot each on top of this. So how many tiles would she need, assuming the tiles are 1 square foot tiles? She would need 240. There's your answer. Did you need this 80? Nope. If you figured out that the other thing was 3, did you need that? Nope. All you needed was that first piece of information. Let's talk about some of these bonus questions now. So they're asking about wrapping paper, 10 feet a roll, or $10 a roll. A roll of red paper, and they give you the dimensions for that. They give you the dimensions for the roll of green paper, and they want to know which one gives you more paper, and how do you know? Wait, that's hard, because one of the rolls is 2 feet across, and 63 feet long. Of course, it's rolled up, but if you unrolled it, that's what it would be. And the other roll is a little bit wider. There we go, I'll make it look wider. It's 3 feet across, but it's not as long. It's 41 feet long. So how do we know which one of these is more paper? You could tell by finding the area, couldn't you? Which one of these has the bigger area? So let's check the area. The first one would be 63 times 2. 2 times 6 is 12, add a 0. 2 times 3 is 6. So we just have hundreds, tens, ones. That equals 6 ones, 2 tens, and 1 100. So 126 square feet for the first roll. Of course, you should stop the camera and figure out the second roll by yourself. And since this is a bonus problem, I'm not going to do that multiplication for you. Of course, you would have to show the work on your paper. But what you get for the second roll is that this one is 123 square feet. So which one is more paper? Definitely the red roll. How do you know? Because you found the area of both rolls. The red roll had the bigger area. So number 13, for $20 instead of $10, I can get a mega roll at another store that is 259 feet long. Should I buy the mega roll or 2 rolls of the paper from number 1? So for $20, which is twice as much money, I can get a roll that is 259 feet long. Well, it doesn't tell me how wide it is. So how can I figure this out? So it's twice as much money, and it's 259 feet long. That's really long. Should I buy this Well, doesn't it depend how wide it is? If it's 1 foot wide, then how many square feet is it? It would be 259 square feet. Is that more than this? It is. Is it twice as much as this? Oh, let's check. Because remember, this cost twice as much money, so I could just buy 2 of those. Let's see, let's do 126 times 2. So let's go back to this book and say 126 times 2. I'll let you figure that out. And since it's a bonus problem, I'm not going to show you the multiplication, but you make sure you show me all the work for that. And when you got the answer for that, 126 times 2, you should have gotten that 2 rolls of the red paper added up to be 252 square feet. This one is 259 square feet. So this one, if it's at least 1 foot wide, is going to be bigger. So that would be your answer. You should buy it if, you should buy the Mega Roll if it is at least 1 foot wide. If it's smaller than 1 foot wide, this is the other one's going to be a better deal. Number 14. I decide to cut up the wrapping paper to cover a wall in the classroom. The area I want to cover is 11 feet wide. What's the longest length of space I can cover with the paper I bought in number 12? I like drawing pictures, so I have a wall. And it's 11 feet wide. So let's say that this is 11 feet. What's the longest length? How long can I make this? Now what am I doing? I'm taking all that wrapping paper that I bought in number 12, and in number 12 I decided to buy 126 square feet. So I have 126 square feet of wrapping paper that I can cut up however I want to cover this wall. So, gosh, what's the longest this can be? If you're stuck on a problem like this, sometimes it helps just to try out a couple numbers. Could this possibly be 3 feet? Yeah, if you made it 3 feet, wouldn't it be 33 square feet? Yeah, it'd be fine, wouldn't I? What if it were 10 feet? Well, this middle part would be 110 square feet. So I'm still fine. How do I figure it out, though, for 126? I could just keep working my way up, or I could use division, because really, I have 126 square feet. That's the area, isn't it? 126 square feet. I want to know what's the longest length. So how could I do this? Area equals length times width. I know my area. I don't know my length. I do know my width. So 126 equals 11L. The next step would be to divide both sides by 11. So L equals, let's see, 126 divided by 11. You should probably be able to do that one in your head, because 11 times 11 is 121, but we'll do it long way. So we have 11 with the remainder, with the remainder of 5. So it could be 11 feet, and let's go ahead and do a decimal. 0.4, and then that would be, whoops, I ran out of room, minus 44. Oops, that's a 5. 11.45, so we can round it to 11.5. So the longest width, actually we shouldn't round up, should we? We should round down. So if we rounded up, we would come up short. So 11.4 is the longest length, and that would be 11.4 feet.